Hi students, welcome to the video lectures of software engineering. So today we'll talk about the testing tactics. So under which first we talk about white box testing. So what is white box testing? So this is also called as glass box testing. We say glass box testing. Okay. So white box testing, sometimes called glass box testing, where our goal is to ensure that all statements and conditions have been executed at least once. Clear? So all the conditions or statements have been executed at least once. Clear? Which means that the white box testing is focusing on the internal logic, control flow, and data flow of the software module. So white box testing, also known as clear box testing and glass box testing or structural testing, is a software testing technique that tests the internal structure, design, code of the software being tested. The tester requires knowledge of the internal working of the application. Clear? So using white box testing method, the software engineer can derive test cases that guarantee that all independent paths within a module have been exercised at least once. Second point, exercise all logical conditions on their true and false side. Third point is execute all loops at their boundaries and within their operational bounds. Fourth point, exercise internal data structures to ensure their validity. So these are all considered as the key objectives of our white box testing. Clear? So what it is saying? To execute all independent paths within the module and then exercise all the logical decisions, that is the true or false outcomes. And then it is saying executing all loops. Okay. The loops in the sense you are, let me write here. All the loops, 0 or 1 or many iterations. Okay. Any. Then finally validate the internal data structures. So these are all the key objectives. Clear? Then we talk about the basis path testing. Okay. So basis path testing is a white box testing technique first proposed by McCabe. Okay. He is Tom McCabe. So the test cases derived to exercise the basis set are guaranteed to execute every statement in the program at least one time during the testing. Okay. Flow graph notation before the basis path method can be introduced. A simple notation for the representation of control flow called a flow graph must be introduced. Okay. So this is about the basis path testing. That is the test case derived to exercise the basis set are guaranteed to execute every statement in the program at least one time during the testing. So if you observe the diagram here, this is the flow graph notation we say. Clear? So the flow graph notation is nothing but, the node that is you are represented by the circle will represent a statement or a block of code. Okay. I'll write here a node which is represented by a circle. Okay. This represent a statement or block of code, right? Then edge is represented by arrows. Okay. What does it do? This will represent the control flow. This will represent the control flow between the nodes. Clear? Then the predicate node is that which has two or more outgoing edges. Okay. So the predicate node is what? Predicate node means which has two or more outgoing edges. Okay. For example, you can consider for if, while, all this. Okay. This is about the flow graph notation. Then we talk about cyclomatic complexity. Okay. Generally, the cyclomatic complexity, it measures the logical complexity and it will give you the upper bound on number of test cases. That is cyclomatic complexity. Let us read this. Cyclomatic complexity is a software metric that provides a quantitative measure of the logical complexity of a program. Okay. In the context of the basis path testing method, the value computed for cyclomatic complexity defines the number of independent paths in the basis set of a program and provide us with an upper bound for the number of tests that must be conducted to ensure that all statements have been executed at least once. This is what is the measure of logical complexity by which we get that upper bound. Okay. So now let us see how to calculate the cyclomatic complexity. So basically the cyclomatic complexity is given by V of G. Okay. Where the formula is like this. V of G is equal to E minus N plus 2 we say. Okay. So here E is number of edges we call and N is number of nodes we say. Clear? V of G is number of regions. Okay. P is for predicate nodes. P we call as predicate node. Where P came from? V of G is equal to P plus 1. Clear? So let us say, for example, let us calculate for 1. So before that, yeah. So steps that should be followed in a calculating cyclomatic complexity and test case design are construction of a graph with nodes and edges from the code, identification of independent paths, and cyclomatic complexity calculation and design of test cases. Okay, this is how it happens. Let us say, for example, let's take a flow graph. Let's take a flow graph. Okay, where E is equal to 11, N is equal to 9. Clear? Now to calculate V of G, what did I say earlier? V of G is equal to E minus N plus 2. E is what? Edges. N is what? Nodes. Clear? Now here we take V of G is equal to 11 minus 9 plus 2. That is 4. Okay. Now predicate nodes, let us take. So predicate nodes P is 3. Now V of G becomes what? As I said here earlier, V of G equal to P plus 1. Right? That is predicate nodes plus 1. So 3 predicates nodes plus 1. That is equal to 4. So now regions are 4. So thus now the cyclomatic complexity is 4. That means 4 independent test paths are required. Okay. For example, let us understand this with a code. If A is equal to 10, okay, then A is equal to 10 given the value. And if B greater than C, then A is equal to B. Else what? A is equal to C. And if print A, B, C. Okay, let's have the control flow graph for the given code. As we saw the code just now, given value A is equal to 10. And the condition if B is greater than C is true, then A is equal to B. And if the condition is false, then A is equal to C. Then print A, B, C, and it stops here the graph. Okay. Now, the graph shows even 7 shapes or nodes we say. You can calculate, okay? 1, 2, 3, 4, 5, 6, and 7. Okay. And 7 lines edges, hence cyclomatic complexity is M is equal to E minus N plus P. E is edges, N is nodes, P is connected components or predicate node we say. So the answer is 7 minus 7 plus 2, that is 2. Okay. And so next we talk about graph matrices. Okay, so when I say these graph matrices, you can understand from the given picture here. So the nodes are nothing but your program logic or conditions or statements we say, and edges here are the control flow arrows between the statements. Okay. Now if you observe the flow, okay, so I will write here. A is traveling from 1 to 3. Okay, the path. B, it's 3 to 4. Right. And then C, 4 to 2. And D, it's 3 to 2. Okay. D. This is what I'm speaking about. Right. Next E, 5 to 4. And F, it's 4 to 5. And G, it's 5 to 2. Okay. So this is the flow. So now E, if you observe the graph matrix, which is given here, so this is the node and this is the connector to each node. Okay. So each cell will contain the label of the edge if a connection exists. For example, if you consider row 1, column 3, that is A is having a connection with node 1. Okay. Understood? So row 1 and column 3, if you observe, there's a connection, right? Next, if you observe row 3, column 2 is having a connection from D to node 3. Okay. D to node 3. Okay. So similarly, the rest. Okay. So now each edge in this flow graph is labeled, okay, from so-called A to G. Okay. And this matrix will show you which edge connects to which two nodes. And this will help us in path coverage analysis and also form some many times for the base of calculating our complexity. That is about graph matrices. Okay. Thank you, students.